In this video, I'll show you how to add a trend line to your analysis. A trend line helps identify relationships in your data. We'll be using the monthly on-time performance data from the Bureau of Transportation Statistics. It contains the monthly totals for domestic flights in the United States. We've got information about total flights scheduled and the percentages of those flights that were on time, delayed, canceled, or diverted. In this video, there's a question that we want to answer. Are there more flight delays when air traffic is high? We'll fit a linear regression model to determine the answer. First, let's create a scatter plot for two fields. In the data pane, select the fields delayed percent and flight operations. Recall that you can select two fields by using Control or Command on your keyboard. Then I'll go over to the Show Me button and expand it, and then let's select the scatter plot. We see a scatter plot with only one mark, and that represents aggregations of our two measures. Let's disaggregate the data by going to the Analysis menu on the top toolbar, and then unchecking the Aggregate Measures option. Now we see each row of data, or every month, plotted as a point. The status bar says that we have 126 marks, and that's because we have 126 months of data. There does seem to be an upwards trend between these two fields. Now let's go over to the Analytics tab. Under the Model category, find Trendline. Drag it onto the canvas by selecting it, drag, and then drop it onto the linear option. A linear trend line is added and it shows an increasing trend. In other words, as flight operations increase, the percentage of flight delays also increase. When you hover over the trend line, a tooltip appears that summarizes the statistical model behind the line. It shows the equation of the line in the form of y equals ax plus b, where a is the slope and b is the intercept. This is the well-known statistical model known as simple linear regression. The R-squared value is a measure of how well the line fits the data. A value of closer to 1 is a stronger fit, and closer to 0 is a weaker fit. An R-squared value of 0.38 is what we have, and this represents a moderate fit. The p-value tests whether a relationship is statistically significant or not, and we have a small p-value, and that indicates a statistically significant relationship. So now we have an answer to our question. Yes, the data does support the idea that delays are higher when air traffic is high. Looking closer, we have some very small delay percentages that seem to be outliers. So let's investigate those further. Let's go back over to the data pane and bring date into the tooltip. And then we can hover over some of those marks. And if you notice, those outliers are actually during the COVID-19 pandemic when significantly less flights were operated. So this is interesting to see. You can right-click on the trend line and select Describe Trend Model. And it will show the same information that's in the Trendline tooltip, plus a little bit more detail. It also has some information in here about a few additional measures of how well the line fits the data. Let's close that. Instead, I'll right-click on the trend line, but this time I'm going to select the option that's Describe Trend Line. Again, it'll show some similar information, but I like this one because it doesn't have quite as much information. So I'm going to select the Copy button. I like to use that to copy and paste the information elsewhere, and then I'll close it. And then I'm going to go over to Excel and then paste that in. And next, what I want to do is show you how to use the model results for predictions. So just below this Tableau output that I've put into Excel, I'll type in num flights and predicted delay. I'll create a few scenarios for predicting. I'll type in 300,000, 400,000, 500,000, and 600,000. And then I'll create an Excel formula to predict the number of delays for each of these 4 scenarios. The easiest way to do that is to copy the equation from the top, and I see it here. So I'll select everything to the right of the equal sign. I will copy it. I'll hit Escape, and then I'll go paste it into my Excel cell here. So I'm going to say equals, and then paste in that formula. So we've got our formula, but you will need to replace the words that say flight operations. And instead, you need to use a reference to the cell in Excel where you typed in your scenarios. In my worksheet, that's A11. And then once you have your reference, you can hit Enter. And then you can copy that formula down to the other cells as well. So if you want to see that prediction as a percentage instead of a proportion, you can use your number formatting in the top menu. And you can increase or decrease the number of decimals that you see. So using this formula for a scenario when we have 300,000 flights, our model is predicting that we would have 9.9% of them that would be delayed. For a scenario where we have 600,000 flights, we would predict that 20.3% of them would be delayed. If we compare these numbers that we calculated to our trend line in Tableau, we should see that they matched because we used the formula from Tableau. For example, if I find 300,000 on the x-axis and follow it upwards to where it touches the trend line, I should see that it touches the trend line right around the point where the y-axis represents a delay of 10%. I want to mention that what we have just done here uses simple linear regression, where we only have one field that's used to predict delays. For a more in-depth analysis, we could also consider other factors that impact delays, such as weather. Adding additional explanatory variables to our model could increase the R-squared value and improve how well our model fits the data. When I want to perform multiple linear regression, which uses more than one field for predicting delays, then I perform that analysis outside of Tableau. For example, software capable of more advanced predictive analysis includes Excel, SAS, R, or Python, among others. Tableau's main strengths are interactive data visualization and descriptive analytics, including some lightweight predictive tools like Trendlines and forecasts. However, full predictive modeling with multiple fields goes beyond its core functionality. I'll end this video here, but be sure to save your workbook.